Hi, welcome to this webinar. This webinar is on feature stores in 2025, and it's a pre-event for the Feature Store Summit, which is happening in online on October the 14th of this year. And we thought we'd do this event because the feature store community is still very active. We expect a record number of people to attend this year. We have some extremely exciting speakers lined up, but I think in the last year or so, we all know that LLMs has massively changed the AI and machine learning space. And there still is the open question of how relevant feature stores are. What's happening in the space? What exciting developments are there? What do I need to learn about that's happening new at the moment? So I'm going to present an outline of the summit this year. We're going to have some great speakers lined up. I'm going to talk a little bit about where we are on the hype curve. I'm going to talk about support for Model Context Protocol, MCP, with feature stores, and how they can be integrated into agents. I'm also going to plug a book that I've just finished writing about feature stores for O'Reilly. And we'll talk a little bit about that in a minute. But that's the basic agenda for today. And I'll start by previewing the summit. So this is going to be our 5th edition. It's called the Feature Store Summit, Real-Time AI, Large Language Models and Vector Databases. So it's really about everything from batch machine learning to real-time machine learning to support for large language model applications and agents. And of course, that's an increasing topic in the space in the last while. So here are some of the exciting talks that we have. For the first time, we're going to have Lyft talk at the conference. So those of you who aren't familiar, Lyft are a taxi sharing service. I think they're second largest in the US market, massive company. And of course, they have a massive deal with AWS. I remember a few years ago where they were going to spend several $100 million over a period of time. So they have, of course, real-time AI is core to their business. So if you're doing a taxi sharing application, you have logistics, you have driver information, you have demand prediction. There's many prediction problems in their space, and they're doing real-time AI, of course. So they're going to talk about how they enable real-time AI for the tens and hundreds of developers they have working there with their feature store architecture. And the second talk I think I'll highlight, and I shouldn't mention at this point, if you have any comments or questions, just drop them in the chat button at the top, and you can basically connect to me there. So the second talk I'll highlight is from Uber, and they're going to talk about scaling embeddings for Gen AI, and how feature store is becoming part of vector indexes are becoming a core part of the data infrastructure that we provide for AI. And that's something that's a definite trend in the last couple of years. So we're seeing more and more feature stores, including a vector index as part of their capabilities. I think Hopsworks, where I work, we were first, I think, in this space to add a vector index to our platform. And now we have a lot of people who are writing their feature pipelines that create the features for their models, but also vector embedding pipelines, and you just write them to the one platform, which streamlines particularly the management of your data infrastructure, that you've one less platform that you need to have. You can get it all in your feature store. So vector indexes are becoming a very interesting trend that they're integrating into the kind of the data ecosystem of feature stores. The next speaker we have is from Pinterest, and this is a first-time appearance from Pinterest. They have hundreds of millions of users and billions of entities, so they have huge challenges at scale. And they're going to talk about some of the scalability challenges. So Andre from Pinterest will talk about some of the scalability challenges that they've encountered and their solutions to those challenges. Another first-time speaker from a first-time company, I should say, Best Egg. And we have Ryan, who's going to talk about a declarative feature engineering approach they have to building features for AI. And as you know, in our community, building feature engineering pipelines has been a challenge, and there's been many different approaches by different organizations. So we have Declarative approaches are really about defining a domain-specific language and then transpiling that into some executable code. And then you have API-based approaches where you do your feature engineering in the framework or language that's out there. It could be Spark or Pandas or Polars or Flink. And these are competing kind of approaches to how you should do feature engineering. So Ryan's going to talk about how they do declarative feature engineering at Best Egg. And then we have a speaker from Roku, again, a first-time company. Roku are one of, I think, the largest manufacturer of video streaming devices in North America. And Krishna will talk about their challenges. Again, it's real-time at scale in creating features and serving them to models so that you can build real-time AI systems. So there's some of the speakers that we have. We have a slightly larger lineup than that. If they start slightly larger, oops, we'll go back here. Let's go back here. So this is, so it's opening up the link to the summit, which is great, but that's not what I wanted to do. So what I want to do is just go to the next slide, which are some of the other speakers that we have. So I should highlight myself at this point. So I've been running the organizing FeatureStore Summit for 5 years, but I've never actually spoken at it. So for the first time ever, I'm going to speak at the FeatureStore Summit. I'm going to talk about, in particular, what I find really fascinating is using large language models to build machine learning pipelines. So how can we enable the next generation of data scientists and data engineers to build feature pipelines without having to maybe learn all the peccadillos of Spark or Pandas or Polars or Flink. And I think we're on the cusp of enabling a new wave of data coming into AI, because building these pipelines has been a challenging job for a lot of people for many years. And if we can really increase people's productivity and their ability to make more data available to models, we're going to really accelerate this AI wave. So that's what I'm going to talk about. We also have iFood, a very large home food delivery company in Brazil, Coinbase. Again, we have a wide spread of companies who have crypto. EY, Ernst & Young, it's the first time for them to speak as well. And then we have Chalk coming back again, a vendor. And we also have Zipline, who are a new vendor in the space. So what's new in 2025 is we have had one new company, vendor, appearing in the FeatureStore space, and that's Zipline. So it'll be their first talk here. We also had one disappear. So Fennel, they talked to the FeatureStore Summit a couple of years ago. They were acquired by Databricks earlier in the year. So that's it on the company side. So where are we in terms of feature stores? Because so I mentioned that this is going to be the 5th year, I believe, of the FeatureStore Summit, which is quite an achievement in itself. I may be wrong, maybe the 4th year, but I think it's the 5th edition. And at the beginning, we were up here at the peak of inflated expectations. So we're going to manage data for AI, but of course, over time, when people see that actually there's more work involved in managing data for AI than just plugging in this magical feature store that magically pulls the data from my data platforms and creates features from it. And we realize that actually, you have to do a bit of work to integrate the system into your existing data infrastructure, and then you have to do a bit of work to build the pipelines and operate them. But I think we're now on this slope of enlightenment. We're seeing now, if we look at the talks that I presented for this year's event, they're mostly very large companies who are generating value with real-time AI, with large language models, with Gen AI. And, so we're moving up this path of productivity, which means, someone else is at the peak of inflated expectations. And of course, that will be large language models and agents at the moment. But I think, this diagram is also a bit simplified in terms of where you are, because if we take agents who are at the top of the hype curve at the moment, they need data to really generate value. They need to be integrated with enterprise data in particular. So agents at the moment and chatbots, they're very well integrated with web search and other capabilities. So, I can go to OpenAI and ask it who won the latest football match for my favorite football team. And it can know from the context that this should provoke a web search, which can then be integrated and answered. But feature stores are the link between enterprise data and Gen AI, and we'll have a look at that in a second. So the most interesting thing I think that brings feature stores into agentic world and large language models is the emergence of a new protocol called Model Context Protocol. So I think it was released by Anthropic not even a year ago at this point, but things are moving very fast in space. And prior to MCP, whenever you want to build an agent could be in a framework like Llama Index or LangGraph or LangChain, and you wanted to use some external service. Maybe it's going to use a vector index, which was the original RAG data source, or maybe it's going to make a REST API call. It could be a web search. It could be an API call to some external service, or if it's a coding agent that wants to read your files because it wants to, help you with your program. Or it could be a feature store API. So you could be able to say, okay, I want to find out, what's happened with this user in the last 30 seconds. What events have they, or what actions have they taken, or what orders have they placed in the last week or two? So feature stores in this case are really about access to enterprise data, but primarily we do this through entity IDs. So feature stores are very much built around the notion of, okay, I have users, I have orders, I have articles, I have items, I have sessions, I have stores, and I can use these IDs to retrieve relevant features that have been pre-computed in feature pipelines. Now these IDs are not really baked into agentic world yet, and I'll get into that in a second. But we'll see that when we bring them into the agentic world, then feature stores are very much opened up for integration with agentic applications. So this is the kind of world we were a year ago, where building an agent and using a feature store or vector index required you writing code directly against those APIs. And now we're in a world where what we call an agentic workflow, where agents can use a large language model to help them decide which of these tools they'll need to use to make progress when a user sends a query in. So for example, if a user says something like, I ordered some shoes last week, where are they, to an e-commerce agent? So the e-commerce agent should be able to figure out, okay, who are you? What was the thing you ordered? What is the current shipping status for those shoes that you ordered? So the agent will take that string and it'll look at the available tools. So Model Context Protocol will expose all of these different services as tools. So the feature store will appear also as a tool, and it will need to provide queries for looking up, for example, orders by user. And the agent will be able to make that call. It'll need to have the user ID, so it'll need to somehow get that user ID to be able to figure out what it was you ordered. But once you send back the list of items that you've ordered, and hopefully you'll have the status of that order, is it shipped or delivered or delayed, and the agent will be able to take that data, send it to the LLM will be able to generate a human readable response. So your shoes were dispatched 2 days ago, or they've been delayed and we expect them to be dispatched later this week. So MCP is the API which will expose our feature stores and make them usable by agents. But let's have a look at how that's happening and what's changing really with the emergence of two main protocols, not just MCP, but the other one is A2A. So A2A is a new protocol. Again, everything is moving fast. This protocol was released by Google in April of this year. It's called the Agent-to-Agent protocol. And we've seen quite high adoption of it as the API for agents. So it's a way in which you can expose the capabilities of an agent. So what can this agent do behind an interface? And when you have that interface, either you have users, here we have an interactive application using the agent, but you could have other agents using that agent as well. So the idea is that this interface is a generic API that can be used by applications, other agents, and so on. So assuming this is the standard that the community will build on, the first point I want to make about integration with feature stores that's interesting is that we don't have to just send the query string in when we're querying an agent, we can also pass in IDs. So in the case of our application here, we may have IDs such as user ID, session ID, product ID, order ID, and so on. So when I send a query to the agent and I ask it about the shoes that I ordered last week, the application knows I'm already logged in, and it will send my user ID along with that query. And if I'm issuing that query from the page where the product is or the order is, it can also send the order ID or the product ID, article ID. So the ID to the agent isn't necessarily just the query string, but we can also take application level context. And I mentioned these application IDs because I think they're the key to opening up the enterprise data to agents. But traditionally, what you would do with an agent architecture like this is you'll have to connect it to a large language model, at least one. And the agent can issue its prompts and responses, and it can generate a plan. So a plan of action when the query comes in, what happened to my shoes? Now, if you have a vector index, which has been the kind of the original, the OG retrieval augmented generation infrastructure for agents, if we take the example of the shoes and the order that I made and the user information, that's already going to be in this application database down here. But how do we get that into a vector index? And I think that's the thing that's not going to happen. So it's pretty clear from what's happened in our space in recent time that the enterprise data that's collected in application databases is not going to be copied into vector databases. Where it's copied at the moment is it's copied into data warehouses for analysis. So Lakehouse data warehouse. And from there, we can get that data into the feature store. So let's assume then the vector index can't help us answer that query about the shoes. So what do we want to do? Well, MCP has come in, so great. We can, integrate external systems, and it's quite a bit of work to integrate a web search or an API to a local or external service. Graph databases are useful there as well. And in general, MCP is great because it abstracts away these as what we call tools. So you ask the agent will ask the tool to execute some function. It'll get a response, and that response is included as context in the prompt that's sent to the LLM. The LLM then tells the agent what to do next, which tool to execute, what parameters to pass on it. So I think the interesting trend for feature stores is that the vector index is migrating into the feature store. So what that basically means is that we don't necessarily any longer have to have two databases, a vector database and a feature store. We can centralize all of this data that we need for our RAG in our RAG databases in a feature store. At least one like Hopsworks that supports a vector index. So what that means is that we can have our documents and files, and maybe you would have a returns policy document that you would index and put in here, and that would be useful for the agent to answer the shoes question. But the more important data is, okay, the order the user placed. So that will get synchronized to the data warehouse, and from there we can have a batch feature pipeline which writes it to the feature store, makes it available at low latency. And then we'll have actions within the application as well. So real-time things that are happening. Let's call them non-verbal actions. So any clicks you make, any swipes, any likes, any shares, all these kind of actions that you take can get streamed into the feature store in less than a second, so that you can really build real-time agents. Another thing that's happening in our space is that agents, of course, generate logs and traces. So again, we want to centralize all of this data for AI in one platform, and that's something that Hopsworks is supporting at the moment, which is storing the traces in the feature store, so that we have one place where we can analyze all our data from the traces for your agent that you can use to run against your evals, to evaluate improvements in your agents or not, as well as the enterprise data from the applications and even the vector index data. So with this, when I issue my query and say, well, where are the shoes that I ordered last week? Well, the user ID will come in here. The LLM will tell the agent to invoke this call on the feature store saying, get me the information about the shoes, which will be on the online store, so a low latency query, which will come back with the results of recent orders. It gets integrated into the prompt. And then the LLM will tell the agent, here's what's the status of the shoes, which will respond to the user. So this is basically how we see feature stores integrating into the next generation of agentic workflows. Now, if you want to learn more about this, I have a book coming out. Now, the reason I'm plugging this at the moment in this mini webinar is because if you attend the Feature Store Summit this year, you will get a free digital copy of the book. If you have access to O'Reilly, I think there's quite a lot of chapters that are available in early release. I have finished writing the book, so it's in production now, and it covers really batch, real-time, and agentic or LLM systems. So how do we build them? How do we integrate them together with the feature stores, this shared data layer that will integrate your feature pipelines, your training pipelines, and your inference pipelines? So if you're building an agentic application, we'll have the feature pipelines become the vector embedding pipelines, but also the batch and streaming pipelines for the real-time data that agents will use. And I'm going to talk a little bit about, present a little bit on it at the conference. So what's interesting about the book is that it's really the first, I think, it's nearly 500 pages. So the first kind of significant book on feature stores. There was a book published, I think, by Pact a couple of years ago, but it was a little bit thinner on, not to be, I think it didn't really cover the space in as much detail as needed. So I think this is the first kind of authoritative account on the space. It does have Hopstrix in there, but it's not, it's generic and abstracts away the important principles, I think. Now, if you're going to, just to plug the book a bit more, so what do we go through in the book? So one of the problems that we do is we build a couple of major systems in the book. One of them is a real-time credit card fraud detection service. And we start with a data mart. And the data mart looks like this. You've got real-time credit card transactions arriving in Kafka. We have some lakehouse tables here related to credit card transactions, the cards, the accounts, the merchants, and the bank details or credit card issuer. And then we look into how do we generate feature pipelines? What features can we extract from this data mart, and how can they help us predict whether a credit card transaction is fraud or not? So it's going to be a mixture. It's a mixture of streaming feature pipelines for real-time signals, batch feature pipelines for slowly changing signals, and then we look into the different models that we'll use to predict fraud and so on. And the other system that the book builds, which is, I think, a very interesting one, it's the world's most valuable AI. So TikTok, their sustainable competitive advantage over YouTube, the reason why they're winning in the video streaming category is because they have this real-time link between when a user clicks and when they get feedback on what TikTok thinks you would like to look at next. So if you're getting interested in a video, or if you're getting bored, it's able to adapt to your actions, your clicks within 1 to 2 seconds. And that really is the differentiation between TikTok. It's what makes it digital crack cocaine, as Andrej Karpathy called it, compared to YouTube. So we basically walk through how to build this TikTok-like recommender platform in the book. So everything from how users will log their events, the clicks that they take with streaming feature pipelines to a feature store, how we collect the data there to train the retrieval and ranking models, how we use the vector index in the feature store to do retrieval. So retrieval is the first phase in this retrieval and ranking architecture. It goes from your billions of videos down to hundreds of candidates. And then we can do very personalized ranking of those hundreds of candidates with a ranking model and extra features from the feature store. And then you get back your ranked list of recommendations here. So, if you want to learn how to build this really high value AI system, then I think the book will be very valuable for you. That's it. It's a pretty short talk today. That's kind of where it's a preview of the Feature Store Summit. It's, as I mentioned, it's happening on October the 14th. If you turn up, you can get a free digital copy of the book, and hope to see you all there. You can join the Slack community if you want to chat about this in advance, and looking forward to presenting the conference for you this year. And that's it. Thanks for attending, everyone. It's been brief, and I hope you all enjoy coming back. Many of you have come back from vacation, that you enjoy the rest of the summer, what's left. Thanks very much.